Right, again, good afternoon. So we're already finished with FET biasing circuits, or how to properly turn on JFET circuit, no, para mo function siya or ma-act as an amplifier siya. Okay, so karon, of course, after turning on the amplifier, after turning on or properly biasing our JFET circuit, the same sa BJT before, the next logical step is for us to analyze our FET circuit sa AC na domain, or the AC analysis of FET circuits. So we need to know unsa ang, or what is the equivalent circuit of the JFET. Okay, so JFET AC equivalent circuit, for us to use it in an amplifier configuration circuit. So the same gid gyapon before sa BJT. After nato bias ang BJT, kay gi-replace nato siya og isa ka circuit model, no? And the only model that we've discussed extensively is the RE model. Mamunta tong gigamit. So dire sa JFET, I think isa ra ka buok nga model ang atong magamit. So this is what the JFET looks like, or mo na iyang equivalent circuit, I mean. So if you look closely, mao gyud siya itsura sa atong BJT gihapon. Mali siya. Muna yung source, muna yung drain, then dilagyan po ng source. As we've known before sa atong learned previously, a JFET or a FET, any field effect transistor, is a voltage controlled current source, diba? So voltage controlled current source. So yung equivalent circuit is inga na gyapon, no? Current source, particularly this one, no? This current source. So voltage controlled current source. Unsa nga voltage, or voltage sa asa nga terminals, unsa nga voltage ang control sa current naga-flow from drain to source, no? Sa kibaling nga voltage. Also sa DC nga part, we've known it to be the voltage across gate and source, or VGS. Okay, so this one, the voltage drop across the voltage drop across here, we call this one VGS. Muna siya nga control sa current nga mo flow dire. Okay, ID, current nga flows from drain to source, or this current source in particular. So this is a supposedly dependent current source. Ang iyang controlling parameter is VGS, and multiplied by its characteristic na parameter. No? I'll name it in a while, but the characteristic parameter, kung sa kuan pa, kung sa BJT, mao na itong ginatawag nga beta, no? Sa FET, especially sa AC analysis, we call it GM. Okay, so GM. So this current, the symbolized by the current source, the current nga mo flow from drain to source, will be controlled by the voltage drop sa gate and source, between gate and source, and multiplied to a parameter GM. So we call that GM the transconductance. Transconductance. And good to know, nagyan pa na siya sa specification sheet. No? Ma-derive na siya sa mga parameters nga sa specification sheet. Okay. So that transconductance is designated as GM. Ana. So sa ning isa. Okay. Ang boundary kibali sa atong FET. No? This is our field effect transistor. Ana. Drain, source, o gate. Kani siya. Yung boundary is this one. This is the device. Or the model that simplifies our device. A current source and in parallel resistor. Resistor, we call this one resistor RD. So ganito sa BJT, RO or RS. RS man to, no? Sa BJT. RO dito sa BJT. So sa FET, RD. Or that's RD. Again, nagyapon ni sa specs, RD. Tawag niya admittance. No? Admittance. Not siya specific na name. Admittance. RD is not the admittance per se, but RD could be computed, no? From a parameter we call admittance. Admittance is nasa specs GOS. So resistance RD, pwede natin siya tawagon nga output impedance sa atong device, no? Dili lahi itong output impedance sa atong amplifier or circuit, that would be ZO, no? But mo man atong device, di ba? Kaning circular figure nga defines the boundaries sa atong device, mo ni siya kibali kana. So yes, no, mo ni siya ang output impedance sa atong device. Okay? Output impedance device, RD. So RD could be computed or could be determined from a parameter sa specification sheet that we call admittance. Reciprocal ang ani kibali. Reciprocal. So 1 over GOS. Measure din ohms. Ohms na ni. Bypass sa transconductance. So that is the output impedance of our device. Bypass sa transconductance, GM, how will we solve for GM? GM is equal to mara siya, kung atong tanawon closely ha, mara siya og first derivative sa atong Shockley equation, no? Observe. 2 ID SS over absolute value sa VP times 1 minus VGS over VP. Muna siya itong GM and muna itong RD. Muna nga mga parameters atong gamiton sa atong model. Okay? And quite analysis di masayon pa ni siya kaysa sa BJT. Samot pag yun nga nakabulan ta saan pag-analyze og mga BJT amplifier circuits. Okay. So, daghan mga configurations na ato na-encounter before. Natay fixed bias, self-bias, voltage divider, common gate, common base. The same ko diya sa BJT, no? Pero isa lang ang ato i-derive. Okay? We'll try to derive at least one configuration. Kaya all the others would follow the same process kung yun sa pag-derive ni nga particular circuit. So, pwede natin magsugod sa or mag-settle for the derivation of the self-bias configuration. So, picture sa self-bias, mayroon siya normal nga configuration nga na resistor sa na isa ka resistor sa tanang terminal. Yan ang itong self-bias. In, out. Self-bias circuit. So, the same sa BJT, ato ipang short ang mga sources, ug atong ipang short ang mga capacitors. Ang sign na pag ni bypass capacitor gyapon dire. So ma-short na siya. Or na siya fixed bias, no? Exactly like fixed bias gyud. Okay, ma-short man eh. Short na ni, short. So padlong na ni ground si RD because na short na po atong VDD. Ang mahitabuan ni ang ato equivalent circuit, i-replace nato ning device, J FET, with our equivalent circuit, si Rs mawala kay na bypass, no? Meaning si source is connected directly to the ground. Source man eh. Kani si drain, kana si gate. Si source would be connected directly to the ground. So kani atong source ground ni siya. Si RD connected sa drain, then RD is connected directly to the ground kay ma-short na atong DC source. Okay? So it's as if na isa ka resistor na po dire. We call capital RD or the resistor sa drain. And si RG is connected sa gate directly to the ground. And since the source is connected to the ground, malag as if naaga na po tayo isa ka resistor dire, RG. So nga itong i-incorporate, no? Shorting everything, shortan ng capacitor, shortan ng voltage source, ato i-invoke ang atong equivalent circuit sa atong J FET, no? So muna atong J FET, no? Ay, nawala dahil dapat nga linya. Ay, pwede na di ay. Okay. Pwede na lang kumagkuan. Ano na lang. So, okay, bali niya ang atong device. Na. Since the source is connected directly to the ground because of this capacitor, adi ang ground. Since na short atong VDD, RD is connected directly to ground, and ang isa ka terminal is connected sa drain. So it's as if naatay resistor dire. RD. Si RS mawala. Si RG connected from the drain to the ground. From the gate to the ground. And since si source is nasa ground, malagnalay Resistor there. No? RG. And that's it. Muna atong equivalent circuit sa self-bias configuration. This is gani VGS GM. VGS GM. Kani RD. Mana? Input impedance measured from here. Output impedance measured from here. And gain is VO over VI. Okay, who'd like to guess how much is the input impedance? Hindi na kailangan i-derive. I think it's fairly obvious. How much is DI? For a self-bias configuration. Okay, very good. ZI is RG. How about ZO? Output impedance. RD lang. I-ignore ang boundary line, no? System boundary line. Plus siya kung series, di ba? Parallel man. So, output impedance is equal to RD parallel small rd. Okay? Okay, voltage gain na lang. Voltage gain, VO over VI. VO is equal to the voltage drop ani dire. VI is VGS naman. No? Naman si VI dire. Dapat naman na siya dire, VI. Dire, VO. VI is directly equal to VGS. But VO is equal to V cos IR. I, sa nga current. Because the VO is the current nga pass through sa itong load. So, ang current only is this current, negative VGS GM times the parallel of RD and RD, or ZO, no? Impedance. So, incorporate na ito nan. Supposed to be voltage gain is equal to output over input. Okay? VI over VO over VI. Okay? VO over VI. And we know our VI to be VGS. VO is this one, current times the equivalent resistance. Negative VGS GM RD parallel RD. So, divide na ng duha. Cancel out si VGS. So, GM RD parallel RD. Negative VGS GM RD parallel RD. divided by VGS. Cancel si VGS. Voltage gain for a self-bias configuration of a J FET amplifier, AV is negative VGM RD parallel RD. Input impedance, output impedance, GM parallel RD. Right. So that's only for the self-bias configuration. So again, no need to derive, no need to memorize kay naatay summary table. Diba? On page 514. So for a self-bias JFET, no? Or even if D MOSFET mag-work gyapon kay similar lang as lang duha og operation. Pero di lang kay ta magamit og MOSFET for amplifier, no? JFET agad exclusively. So for a self-bias JFET, ZI is RG. ZO is RD. RD parallel RD, no? Kung masatisfy ning kang condition, kaya pa ni. So mas better nga kanila itong gamiton, no? And as for the voltage gain, dila, negative GM RD parallel RD. So it's a medium range na amplifier. Okay? So di na ito i-drive ang uban. For the fixed bias, if you've observed, pareha ra. Pareha ra. Kaya ang fixed bias ug ang self-bias nga naay capacitor, equivalent la. No? Self-bias unbypassed, meaning walay bypass capacitor sa RS, medyo complicated gamay ang formula. So, at least nara dire. The only new thing na atong na-add today is ang formula for GM. Okay? Question so far? Okay? I hope so. So, palalagid og pamaagi ha sa kuan sa BJT. I think it's better to solve one example. Ako kay drawing ha. Dos ako. Example, this one. We are given a two-stage amplifier circuit, both of which are self-bias na ay capacitor na mo bypass sa Rs. All of the values are the same. Rg is 3.3 mega ohms, Rs is 680 ohms, and Rd is 2.4 kilo ohms. Device parameters, IDSS is 4 milliamperes, Vp is -4, and small Rd is 30 kilo ohms. Lang. So, question, required is the total voltage gain. Namantay load nga 1K. So, what do we do? Na tungod the same na sila nga klase nga amplifier, identical lagi kaayo. Pwede na to ma-solve ilang individual nga no-load voltage gains. No? So, atong giderive ganina, this one, the same sa BJT, this is the unloaded voltage gain. No? So, after nato makuha ang unloaded nga voltage gain, atong i-plug in, actually magamit na to ilang ang mga given na or mga calculable na input impedances, output impedances. And i-take into consideration atong RL, kuha na to ang loaded voltage gain sa first amplifier o sa second amplifier. Multiply na to ang duha, kuha na to ang overall loaded voltage gain. So the same lagi sa BJT. No? Ang taas lang nga part is the same as sa biasing ng pagkuha sa ID. No? Okay. I think mo na itong first nga pangitaon nun. Solve for ID. ID is IDSS. One minus VGS over VP squared. So, may self-bias. So, di na ako magkuha na, di na ako mag-derive. Mag-refer na lang ko sa akong table. VGS is negative IDRS. Where VGS negative ID RS. Plug na ito na dito. BP is -4, IDS is 4 milliamperes. Let ID be equal to X. X is equal to 4 milli. 1 minus RS is 680 ohms. So 680 X over VP is -4. Cancel lang, -1 is -4. 4 squared. 680 divided by 4 is 170. Expand 1 minus 2 times 170 is 340x. 170 squared is 2,900. Distribute 4 milliamperes. X is equal to 115.6 x squared minus 1.36x plus 4 milli. Expose me to the other side para madungagan ng isa, 2.36. So 115.6x squared plus 2.36x plus 4 milli equals 0. Solve for x. Ang isa is 18 milliamperes, layo kayo sa 4 milliamperes. So, ang isa ka-answer ani, mulampas na sa 4 milli. And the other one is 1.865. Therefore, ID is 1.865 milliamperes. Then, we could solve for VGS. VGS is equal to, kani multiply og 680. 1.267, negative 1.268. Okay. Question so far sa DC analysis. Wala. Wala. Wala man iba. This is the same as before. Now let's solve for GM. Hindi na rin magsulat ng AC. Pag-calculate sa value sa GM. GM is 2 IDSS over absolute value sa VP times 1 minus VGS over VP. Wala squared. IDSS is 4 milli. 4 I think correct ni. Minus supposed to be. Kasi GS is negative man, so pero negative man si VP. Retain lang ako. Such that GM is equal to 1.37 milli. No? Milli? Oh. Millisiemens. .37 millisiemens. Reciprocal sa ohms na yun, di ba? So that's our GM. So, okay. Kuha na to ang, siyempre, kung na itong ZO, ZI, wala pa na siya. ZO is RG. ZI, I mean, ZI is equal to RG. Meaning ZI is 3.3 mega ohms. ZO is RD parallel RD. And small RD is given as 30 kilo ohms. Ang RD, ito po, 0.4K. 4K parallel 30K. So given sila. $2.22 kilo ohms. Ito. Next, voltage gain is equal to negative GM times RD parallel RD or ZO. Which is GM. 1.37 milli. 0.2 kilo. Pilan eh? Negative 3.02. More or less negative 3. No? Kasi nato i-round off kasi nga ni. Remember, this is still unloaded. Now, with the or considering natay load nga 1K, lahi ang ilahang loaded voltage gain. No? Lahi mo sila og output impedance nga kakakita, no? Or load nga kakakita. No? So, how about start sa uno? So kung ato i-draw, drawing sa ato, no? System's point of view. Plus lang mga unloaded nga parameters. Previously, we've known that the loaded voltage gain is equal to AVNL times RL over RL plus own ZO, output impedance. So for AVL1, -3. Now, what is RL? What is the RL nga kakita ni amplifier 1? Pilay value. Same like formula. Paabot sa, with the effect of RS and RL, the same lang ang formula as before. Ito, 3.3 mega. Yes, kaya ang input impedance sa second stage is mo ang makita nga load ni first stage. So yes, it's 3.3 mega. 3.3 mega over 3.3 mega plus yung output impedance is 2.2 kilo. Which is very much negligible. Meaning, AVL1 is still approximately equal to -3. No? $2.999998. Free lagi hapon. Si AVL2 -3. Oh, at least ha. Ang yung RL, the second stage is of course our actual load 1K. So 1K plus over 1K plus 3.3K. 2.2K. Tama na. Negative 0.94. Negative 0.94. Kung itong AVL1, and AVL2, to get the total loaded voltage gain, multiply ang dua. No? Negative 3 times negative 0.94. Negative 2.8. Positive na rin. So, positive 2.8. Any clarifications? Is it exactly the same process as before? Okay. Especially sa considering nga napabuhatan mo before katong design nga problem. So for sure, sayo na rin sa inyo ha. If naalang taan VGS-GM, wala na siyang kuan. General na siya or mo na gina siya ang value sa atong equivalent circuit. Diba? VGS-GM lagi yan. Para na sa tanan. So if nataan no need to derive. Summary table for DC. DC nga analysis for JFET, and summary table for AC, ZIZO, and AV. Dali na ito, solve to. Then, doon ka book nga formula itong sort of memorize on, no? If there's something man nga dapat na ma-memorize, it's the Shockley equation and the equation for transconductance, which is derived from the Shockley equation gyapon. So, mas dali, kibali, mas dali magamit or mas dali ma-design ang JFET amplifier. And for amplifiers using FETs, JFET atong gamiton exclusively. Okay? Ang MOSFETs, lahi po na iyahang kuan, lahi po na iyahang marag forte. Okay? Questions so far? If wala na, we could dismiss early. No? Dito lang tataman. By Friday, siguro mag-solve tag few examples ani. Next week, muna na taog chapter 8. Next week, operational amplifiers na dahil ta. Oy, kung anong next week, no? Liwik naman di gani. So, Tuesday na to next week magkita. No? Kaya lang op-amp next week. Okay. Sige.
Yes, sir. Salamat, sir.
Sige. Okay. Thank you, Sad.
Thank you, sir.
Dinner. Karong Friday, mag-meet pa ta. Meet pa karong Friday. Okay, bye-bye.